So in this question here, we've got a box being pulled at an angle of 45 degrees with a force of 85 newtons. The coefficient of friction along the horizontal plane is 0.4. What we want to know is what's the mass of the box if the whole thing is in a state of equilibrium. So how are we going to go about working this out? Well, first of all, let's draw a forces diagram and see what's going on. So that's my horizontal plane. Here's my box represented by the rectangle there, and the mass of that, which we don't know, which is what we want to find, is labelled inside as M. Now the force we're given is 85 newtons at an angle of 45 degrees. So let's draw that force there like that, and the angle 45 degrees. Okay, right. Now, the forces that naturally act upon that box is first of all the force of gravity. So the force of gravity will be the mass of the box times the gravitational constant, which we are given here in the question, which is more than often 9.8. Okay, so now what we want to know is what are the forces to keep this in a state of equilibrium. Now what we have here is we have the forces acting upon the box in a vertical way to counteract this force. So that one we'll call our force R, our resultant force. And then we'll have the horizontal force counteracting the force going this direction, which I'm going to call my force F. Okay, now what we're looking for is a relationship between these two forces to find our mass, and that is that our force F is less than or equal to mu, which is our gravitational constant, times our resulting vertical force. Okay, right, how do we go about calculating these forces? Well, let's calculate force F first. That looks like the most straightforward. So the force F is the force going this way on this box in this direction. So as it's in a state of equilibrium, the force going this way will equal the force going this way. So the force going this way, what we're needing is the magnitude of this part of the force, i.e. the horizontal. Now if we use a little bit of trigonometry and draw a right angle here, we'll see that this force here, we can use a cosine. So cosine, as it's adjacent, cosine of 45 times the 85. So force here is 85 times cosine of 45. Well, cosine of 45 is root 2 over 2. So that equals 85 root 2 over 2. So that's our force F. So now we need our resulting vertical force. So now to calculate R, we'll have this force acting in this direction here, subtracted from this force in this direction here. So as it's in a state of equilibrium, then that should all equal the force going upwards. Okay, so we'll have this force here, which is M times G. And then we'll subtract that from this force going in this direction here. So the force going in this direction, again using trigonometry, we'll see that it's the opposite one. So therefore we use sine of 45. So therefore we have minus 85 times sine of 45 degrees. So 85 would be our hypotenuse for our magnitude. Okay, so let's simplify this off a little bit. Well, our M we don't know, G is 9.8, so let's write that in. So we've got 9.8 M minus sine of 45, that's also root 2 over 2, so that's minus 85 root 2 over 2. Okay, so we want to use this relationship here. So F is less than or equal to mu times R. So therefore we'll have F, which is 85 root 2 over 2, is less than or equal to mu, which is 0.4, which I can write that as 2/5, as we've got some fractions going on here in the results so far. And then multiply that by our force R, which is 9.8 minus 85 root 2 over 2. 9.8 m minus 85 root 2 over 2. So we need to just get this m on its own so we know the mass of the box. So let's multiply everything by 2/5. So now we've got 85 root 2 over 2 less than or equal to 9.8 times 2 is 19.6. 19.6 over 5. So let's just write that as that. 19.6 over 5 minus, right, let's multiply this by 2 and then divide by 10. So 85 times 2 is 170, divided by 10 is 17. So it's minus 17 root 2 as it is. So that takes care of that, not forgetting the variable m with this one here. Okay, right, now let's add 17 root 2 to both sides. So let's continue up on this side. So we've got 85 root 2 over 2 plus, now if I add 17 root 2, it would be good if I could get a 2 in my denominator to get the same fraction. So if I double it and leave it divided by 2, that would be 34 root 2 over 2. And that's less than or equal to 19.6 m over 5. Okay, right. Now I can just combine these fractions here together. So I'll have 119 root 2 over 2 is less than or equal to 19.6 m over 5. So now if I multiply both sides by the reciprocal of this coefficient here, so now I'll have 5 over 19.6 times 119 root 2 over 2 is less than or equal to my m, because that will cancel out on this side. So if I put that into a calculator, I'll get that my mass is going to be less than or equal to 21.466. So let me just write that here. So mass is going to be greater than or equal to 21.466 kilograms. So therefore, if my box is 22 kilograms, this will be in a state of equilibrium. If it's less than 21.46, then the box will start moving. Okay, that completes our calculations.